Hi guys, my name is Peter C. Dogba Jr., your mathematics instructor at the University of Liberia and your math tutor. In my today's lecture, I will be discussing differential equation, and this is a continuation of our lectures under determining the order and the degree of a differential equation. We did example 1, we did example 2, and example 3. So we have example 4, and within example 4, we have two problems. So I want to look at the two of them and see how we can easily determine the order and the degree of each differential equation. So basically, we have a hint that whenever we have a differential equation and we want to determine the order and the degree, the first thing we need to identify is what is the highest derivative within that differential equation. That's the first and foremost concern. So we look here, dy by dx. So dy by dx indicates first order. d2y by dx squared indicates second order. d3y by dx cubed indicates third order. Dot dot dot. dn y by dx raised to the power n indicates nth power. So this is not equal to dy by dx all square. No, this doesn't mean the second derivative. No, this is the first derivative, but it's raised to the second power. So it means in there you have the degree to be 2 and the order to be 1. So the highest derivative here is just 1, meaning our order is just 1. That's the order. So to determine now the degree, we must first simplify. So because we observe that under this square root, we have a derivative here that is, a kind of, raised to some second power. In fact, the entire expression is raised to the power 1 over 2, which is a fractional power. And this term is one of, the concentration, the main concentration of the problem. That is the highest derivative of the problem. So we need to be able to solve for this. So what we do now is we can send this term across the equal sign. We have x dy by dx now equals a. So we can say 1 plus dy by dx all square. And this whole thing, remember, square root means 1 over 2, half. So if we can just raise both power, because we want to get rid of this square root, so we say we raise both to the power of 2. So we raise this to the power of 2 and this to the power of 2, so that this 2 can cancel this 2. So we'll now be left with y minus x dy by dx raised to the second power. So it means we can multiply it twice, x y by dx. Now, this expression that is here, right? This is a times bracket opens 1 plus dy by dx all square raised to the power half. So this is raised to the power half. But remember, it is this entire expression that we are raising to the power 2. So this 2 must be raised. Let's say this expression must be raised to the power 2. This a must as well be raised to the power 2, because it is each factor on the right hand side of the equation. So therefore now we have our a square. We have a square times 1 plus dy by dx all raised to the power 2. So we've gotten rid of the fractional power. Gotten rid of the fractional power. So we can just further simplify. But without simplifying, we can be able to identify the degree and the order. But let's further simplify so that you have some detailed understanding. So y times y is y squared. Y times x is xy dy by dx. So if we multiply x, y again, dy by dx, it will just give us negative xy dy by dx. So the signs are the same. We're adding them. So this will just give us 2. It will give us 2x dy by dx. So we take this term from there. And then we'll do the last one. This time this. So it's positive x squared. And then dy by dx all square must be equal to a squared times this one times this one now again is a squared dy by dx all square. So if we like, we can group this and this, but this is not our concentration. Our concentration is to be able to find the order. So we know the highest derivative is just first order. So the highest derivative is 1. So order is 1. And then the degree now, the power of the highest derivative is 2. So the degree is 2. So in this problem, again, what is our highest derivative? Our highest derivative is just the second power, right? So the order is equal to 2. But we also need to identify what is our degree. We can just say the degree is 1 because this is raised to the power 1. No, we can't just say that. We have a fractional power here, so we can be able to get rid of that fractional power. So it means this side and this side now can be raised to the power of, because we want to get rid of this denominator, so we can raise it to the power 2 and raise it to the power 2. So 2 now, we cancel this 2. So you'll be left with 1 plus dy by dx, all raised to the third power, equals, so a raised to the second, and this expression d2y all over dx squared raised to the second. So no need to expand, because even if you expand, this first derivative dy by dx will be raised to the power 3. And then this second derivative is raised to the power 2. This can never be our degree, because the degree must be the exponent of the highest derivative. And this is not the highest derivative. So this is our highest derivative. So the degree is just equal to 2. So this is how we find the order and the degree of a differential equation in our last set of problems. So we ask you to watch our subsequent videos. We'll be looking at verifying differential equation. We'll be looking at eliminating arbitrary constants. We'll be looking at families of curves and few other topics. So thanks ever so much. See you in our next video.